Let's look at the parameters of OmniLight. And the parameters for OmniLight are the same, very similar parameters that you would find with the other light sources. So you have something, a switch for on or off. Is it on or off? Pretty self-explanatory. You can also change light types right here at any time. So you can change, if you decide, oh, a spot is going to work better, you can always change it to a spot, and now all of a sudden it's a spotlight. And then you can choose whether or not to make it targeted. And so you can, at any time, really toggle between any one of these three basic types, or actually, three basic types that we're talking about, and then target and free. You can toggle them back and forth between target and free whenever you want. So it gives you a sort of a more specific way to create lights, but you can just flip back and forth whenever you want. So let's go back to Omni for now and look at some of the very basic parameters of light. What an OmniLight is it is a point light source that emanates light in all directions evenly. And realistically, that's what really most light sources are. They are light sources that emit light from all directions. Okay, even if you have a light that's in a housing, the light that's in the housing is emitting evenly. It's just that the housing, intercepts the rays before they get anywhere and cast shadows. But so realistically, all lights are OmniLights. Even things like the sun. It's just one big, far away, ginormous OmniLight. We don't necessarily use an OmniLight to simulate the sun. There's other ways to do that. However, conceptually, that's what it is. So there's some settings for shadows, which we'll come back to in a second. Lights in 3D software don't cast shadows immediately. Now, there's, in the real life, there's no light without shadow. It's implicit. It's a function of being a light. They're inseparable, right? But in computers, you have to specify a shadow. I'm going to come back to this in a second. Let's look at some of the other parameters first, these intensity, color, and attenuation parameters. So here you have this multiplier. This multiplier is essentially the intensity of the light, and so as I decrease the intensity of the light, it's going to turn on or off essentially, go up or down all the way to 1, beyond 1, way beyond 1, etc., etc. So if I want a light to be half as bright, I just half that number. Color is the light's color. Again, pretty self-explanatory. You just pick it and say, if I want a purple light in here, say okay, I have a purple light. And now in here you have this thing called decay and near and far attenuation. And the way these things work is a little bit, I don't want to say complex, but they all sort of interoperate. And if you have some of this enabled, it's going to affect the way it decays, or if you have decay enabled, it's going to affect the way it attenuates. They're all kind of doing the same thing. And what they do is, in 3D Studio, or any 3D application, in general, lights don't, a light's brightness is the same at right at the light as it is infinitely far away. And now that's not intuitive at all. We know that from the real world, a light's intensity decays with distance. So if you're right near a light, it's going to be brighter than when you're farther away. So things, as they get farther away from lights, get dimmer, right? They're not lit as well. Now, that isn't how lights work in 3D software. You can see all this stuff here is equally bright everywhere from this light. And so what you have in order to simulate that decay with distance is you have these three things: decay, near, and far attenuation. Decay is first here because this will allow 3D Studio to use an equation to specify how light is going to decay with distance. So you've got inverse and you've got inverse square. Now when you see I've enabled some kind of a decay, my light is going to all of a sudden get a lot dimmer. When you use some kind of decay, you're going to have to increase that light's intensity by potentially quite a bit. Okay, because it is dimming with distance, so it has to be far more intense here at the source. So we have inverse and we have inverse square. Now inverse square is actually physically correct, but to be honest, we don't use it very often in computers because it just tends to be too dim, and you end up, in order to get the light illuminating anything at all, right, finally it's illuminating something, I'm at this intensity of almost 10,000. It's a multiply of 10, 9,000 some odd here, and that is incredibly bright. And what happens is, as if that light gets even remotely closer to anything, it's just going to clamp it out and just go nuts on objects and textures and that sort of thing. So we very rarely use this inverse square decay type. More common to use inverse, and then when you use inverse you can have numbers that are a little bit more sane. 50 is still quite a bit, but it's better than 10,000. Now you also have the start parameter, and the start parameter essentially, I can click show and it will show exactly where it's going to start. That start parameter is how far away the decay is going to begin. So up until that distance there is no decay. Up until this distance, once the light is full intensity up until this distance, once it hits this distance, then it begins the decay of whatever you've got selected here. There's another way, a more specific way to manage this attenuation. You have these two numbers, near and far attenuation. Now what those do is those state where a light, the light's value goes to 0. So with far attenuation, a light is a certain brightness up to this number, begins to fall off, and is completely 0 when it gets to this distance. Now with near attenuation, the light value actually is 0 up until this start point, and then at this end distance it ramps up to full intensity. So actually far attenuation is much more common to use. Near attenuation is a little bit it's a little bit weird. You could use it for special cases where you want to contain a light within a specific place. But let's take a look at it. So if I put far attenuation and I say use, now all of a sudden the light is going to turn off and it's going to start attenuating. Okay, I won't need to increase this value. If I increase this top value just by spinning it up and then spin it back, you see end always has to be greater than start. And so the way I like to use this is just spin up start until that's where I want it to stop, and then I back this off and decide where I want it to start falling off. So what's going to happen is the light is going to be full intensity within this inner sphere, and then it's going to drop off to 0 from here to here. So that's far attenuation. And it can be a really good way of ensuring that light is not going to get in some regions that you don't want it to get. And so if I have if I have this light, which is going to serve as one of these two lights up here, then if I know I want that light to fall off by the time it gets to here, I simply increase the end attenuation, and I know it's not going to go past that point, but I know that I want it to be bright enough to illuminate the backside of this trailer. I can start it here and end it here. So I have very fine control over where exactly the light is going to be in this scene. So if I go ahead and render this, I get exactly what I expect. So the light is full intensity up to here, and then I have control over where that light ends. Now, this show checkbox, with show checkbox checked, it doesn't seem to do anything. What it does is simply show the attenuation even when I don't have the light picked. So the attenuation of any light is always going to show when I have it picked, but if I uncheck show and unpick the light, then it goes away. So it's just a way to always show it if you need to see it at all times for any reason. And so with near attenuation, if I choose to use it, I can take this start range, take that all the way up, and what this is going to do is this is going to ensure that this light is nothing inside that little blue circle. So the light value is going to be nothing up to here, then ramp to full intensity, then then stay at full intensity up to the start of far attenuation, and then ramp down to 0 intensity at the end of far attenuation. So you have nothing, ramp up, full intensity, ramp down. That's what those do. So if I render this, we see that that's what it's doing. So it's no intensity inside that near attenuation sphere. So I don't very often use near attenuation, to tell you the truth. If it's, again, a special circumstance, sure, where you don't want light inside a certain thing, you want a ring for some reason, but not very often. Far attenuation is far more common to use. Now you can see if I take this and render it again, get rid of that little near attenuation thingy.